the position, velocity, and acceleration in polar coordinates. So when do we use polar coordinates? When we can describe the motion of the particle. So let's say that the particle is moving from here upwards, and let's say the position of the particle at some instant of time is right here. So this is the particle. So when we can find the position of the particle with respect to the origin with we can describe the motion by r. So that's the distance of the particle from the line, a random line like this, about which we measure the motion, and theta is the angle made by the particle in time t. Then we can use r theta coordinates. Okay, so just like this ut, un, I, j, k, similarly there is ur, u theta for this particular coordinate frame. So I'm going to draw ur, and we modify this a little bit, slightly skew. This is 90 degrees. This is u theta. So the main point I want to make is that u theta need not be tangential to the particle. Ut, on the other hand, the ut and un were talked about in the last class. Ut is actually tangential to the motion, but u theta is not tangential. So this need not be tangential to the motion of the particle. So it's along the direction where theta is increasing. Okay, so let's now try to write position, velocity, acceleration in this frame. So the position of the particle, I'll denote that by r, is simply the vector r, sorry, the scalar r times u of r the velocity is, well, let's call it v. It's simply the rate of change of r with respect to time, and the book gives a derivation of how to derive r dot. I'm just going to write the formula. It has two components. There's a vr, which is along ur, and there's a v theta along a u theta. So vr is r dot, and v theta is r times theta dot. We should also put the magnitude of velocity. Sometimes you're asked to find the magnitude of velocity. That's simply r dot square plus r theta dot square. So take the ur component, take the theta component, and then take the square and sum them up. Acceleration is denoted by a. That is simply the rate of change of velocity. Okay. Again, the book gives a derivation of how to find v dot from that formula here. I'm just going to write the formula down. So it's got two components again. There's a AR acting along UR, and then there's a theta acting along U theta. And these components are given by the following: R double dot minus R theta dot square UR plus 2R dot theta dot plus R theta double dot U theta. Okay, the final thing is the magnitude of acceleration. It's simply the squares of the individual components. So it's R theta dot the whole square plus 2 R theta dot R dot theta dot plus R theta double dot square. Okay. Okay, so let's just try to use all these things in a few problems. First question is this. So a particle is moving along a circular path having a radius of 4 inch such that its position as a function of time is given by theta equals cosine of 2t, where theta is in radians and t is in seconds. Determine the magnitude of the acceleration of the particle when theta is 30 degrees. So we're given that the radius is 4, okay, right here. We're also given that theta is cosine of 2t, and we are asked to find the acceleration, the magnitude of the acceleration when theta equals 30 degrees. Okay, so we are asked to find magnitude, which is simply R double dot minus R theta dot square, the whole thing squared, plus 2 R dot theta dot plus R theta double dot squared. Okay, so this is the unknown. So if we can find the various derivatives of r and theta, we should be able to solve for acceleration. So let's just try to solve for the first and second derivatives of r and theta. So we're given that r is 4. Okay, what is r dot? R dot is dr dt. So what's that? It's 0 because r is a constant. And then r double dot is simply d square r dt square is also going to be 0. Okay, so that's super easy. The next one is theta is cosine of 2t. Okay, so we need to find theta dot, which is d theta dt. Okay, so I don't think we'll be providing you with tables for derivatives of simple functions. So you got to remember how to find. You've got to remember the formula for the derivative of cosines and sines. So what's the derivative of cosine? It's negative sine. Yeah, times you need to also take the derivative of this thing, 2t. The derivative of 2t is 2. So that is minus 2 sine of 2t. We also need to find theta double dot, which is d square theta dt square. That's going to be minus 2 as it is. Then derivative of sine 2t, which is cosine 2t, times the derivative of 2t, which is 2. So it's minus 4 cosine 2t. Okay, so we are after this expression here. We have evaluated our dot and our double dots, as well as theta dot and theta double dot, right? However, we have a numerical value for r's. We do not have a numerical value for theta. We only know an expression for theta as a function of time. We need to find numerical values for theta and its derivatives. So we can only find the numerical value if we know what t is. But we are not given t. We are only given that we need to find the values where we need to first find how t is related to theta, or theta is 30 degrees. So my question is, how can I find t if I know that theta is 30 degrees? Yeah, so I can put this theta inside this expression and find t. And once I know t, I can sub it here to find theta dot, theta double dot, and then sub it in case. Okay, so to do that, we know that theta is cosine 2t. So theta is okay. So there's an issue here. I need to this theta is in 30 degrees, but the theta over here in this expression is in radians. So I need to convert degrees to radians because of this. So 30 degrees in radians is pi divided by 180. So if I multiply by pi divided by 180, I can convert degrees to radians. So this gives me pi divided by 6 is cosine 2t. So t is cosine inverse, well, that's half cosine inverse pi divided by 6. This 2 is because of this 2. That comes out to be yeah.
I was wondering, if we were to have like before, like equal equation and move the cosine inverse theta equals 60, do we have to still change here, or we could have left it? So we have to convert radians.
So the theta here in this expression is in radians. When we write this, we have the option of writing 2t in degrees or radians. Just a matter of how to interpret that. If you write it in this is the way it is, it's in radians. I didn't tell you that it's in radians, but most times we deal with radians and not in degrees. I would specifically tell you if it's in radians, yeah. So this gives me t is 0.51. So what I can do is sub t equals 0.51 in 1 and 2 to get theta dot equals minus 1.7 radians per second, and theta double dot equals minus 2.09 radians per second square. So now we can values in 3, which is my acceleration formula. The acceleration comes out to be, you can check this, it's what I got is 11.61 square plus 8.38 square, which is 14.3 inch per second square. Okay. Any questions? So that's a fairly straightforward question. The only trick here is you're not given time, you're given theta, and you need to know how to convert from go from theta to time. That's the only tricky part. Otherwise, it's a straightforward application of the formula and knowing how to take the derivative. Inch per second square, because the radius is an inch. Any other questions? Okay. Okay, next question. So the car travels along a road for a distance defined by r equals 200 divided by theta feet, where theta is in radians. If it maintains a constant speed of v equals 35 feet per second, determine the radial and transverse component of velocity when theta is pi divided by 3. Okay, the radial denotes ur. Okay, the transverse is u theta. So we got to find VR, which is r dot, and then v theta, which is r theta dot, are the two unknowns. Okay, what we're given is that the magnitude of velocity is 35 feet per second. That's this information. And we're also given that the radius r is a function of theta, and given by this formula. So I can write this down in this fashion. V equals 35 equals r dot square plus r theta dot the whole square. So this is from the formula I gave earlier. It is the square of the r component plus square of the theta component. Okay. So that's using one piece of information. I need to find r dot. I need to find r theta dot. I know what r is, so I can just sub that in there. I can sub in r here, but I still don't know what r dot is and theta dot is. So I'm going to take the derivative of r dot, because I know r. So r dot is d dt of 200 divided by theta. So 200 comes out. I need to take the derivative of 1 divided by theta. Okay. Now theta is a function of time, so the derivative of that is going to be minus 1 theta dot theta square d theta dt, or minus 200 theta dot divided by theta square. Right, because derivative of 1 divided by theta is that, and then theta is a function of time, so it's the chain rule, d theta dt. Okay, so going back, I need to find r dot, but r dot is 200 divided by theta square times theta dot. I know what theta is, it's given as pi divided by 3, but I don't know what theta dot is. So unless I find theta dot, I will not be able to find r dot, and unless I find r dot, I will not be able to find a VR. Similarly, if I want to find v theta, it's r times theta dot, and theta dot is an unknown. So theta dot is if I can find theta dot, I can solve this problem. So the way I can find theta dot is use the other expression which I have not used, which is the magnitude of velocity. So let's try to use this expression now. So 35 equals r dot square. R dot square is minus 200 divided by, I'm going to sub in the value for theta now. It's pi divided by 3 square times theta dot, the whole thing squared, plus r, which is 200 divided by theta, so theta is pi divided by 3 times theta dot squared. Okay, so if you look at this expression now, the only unknown in this expression is theta dot. I need to solve for theta dot. So I can square this, sum it up, since it's going to be theta square, theta dot square, I can pull that out and then solve for theta dot. Okay, so I'll leave that to you. What I get for theta dot gives theta dot equals 0.1325 radians per second, and now I can solve for v, which is r dot, which is minus 200 divided by pi divided by 3 square times 0.1325, which is simply minus 24.2 feet per second. And so this is Vr. V theta is r theta dot. R is 200 divided by theta times theta dot is 0.1325. So V theta is 25.3 feet per second. Okay, so if a particle moves along a path such that r is 2 cosine t in feet and theta is t divided by 2 in radians, where t is in seconds, determine the particle's radial and transverse components of velocity and acceleration. So essentially it's asking you to find the velocity vector, which is dr and v theta, and acceleration vector, which is ar and a theta. So this is probably a straightforward problem. Let's try to set this up. So V is VR UR plus V theta U theta. So VR is R dot UR plus V theta is R theta dot U theta. So we need to find r dot and theta dot, right? So r is cosine, so 2 cosine t so r dot is going to be minus 2 sine of t. Similarly, theta is t divided by 2, so theta dot is just half. So v is minus 2 sine of t ur plus 2 cosine t, that's the value for r, times theta dot, which is half. Minus 2 sine of t ur plus cosine t u theta. Okay, so in other words, Vr is the radial component, is minus 2 sine of t, and V theta is the transverse component of the velocity, that's cosine of t. Okay, we still have to find the acceleration. So the acceleration is again ar ur plus a theta u theta. Ar is r double dot minus r theta dot square ur plus a theta is 2 r dot theta dot plus r theta double dot u theta. Okay, so here we need to know, besides the first derivative, we need to know the second derivative of r and theta. So r double dot is, we can use this, you know what r dot is, so it's minus 2 sine t, so r double dot is minus 2 cosine t. So using 1. Similarly, theta double dot is going to be the derivative of half, which is 0. So now acceleration is going to be minus 2 cosine t minus r, which is 2 cosine t times theta dot square. Theta dot is half. Plus 2 r dot. R dot is minus 2 sine t. Theta dot is half. Plus r plus theta double dot, which is 0. So this comes out to be 4. That's going to be minus 2 minus half, so it's minus 5 divided by 2 cosine t u of r. That's minus 2 sine t. Okay, so AR is the radial component. It's the first term, minus 5 divided by 2 cosine t, and A theta is the transverse component. It is minus 2 sine of t.